Hello guys, in this video I will be answering a question based on momentum. Basically my cousin started studying, he's in college now, and he just asked me this question. He needs help on it, so I decided to answer it by making a video and put it on YouTube so it can not only help my cousin, but it can help other people. Okay, let's read out the question. It says, in a laboratory experiment to measure the mass of an object X, two identical trolleys A and B, each of mass 0.5 kg, were initially stationary on a track. Object X was fixed to trolley A. When a trigger was pressed, the two trolleys moved apart in opposite directions at speeds of 0.30 meters per second and 0.25 meters per second. And this is the image. Okay. The first part of the question states that asks us which of the two speeds given above was the speed of trolley A. Give a reason for your answer. Well, the trolley B moves away faster, and that's because the mass of A and X is greater than B. Okay, very simple. So trolley B moves away faster because mass of A and X is greater than B. And so this means that the speed of trolley A is 0.25 meters per second. So speed of trolley A is 0.25 meters per second. Let's just quickly label that on our graph, in our image. Okay. Okay. So the second part of the question states that show that the mass of X must have been 0.10 kg. So what? So we need to think about the conservation of momentum, right? Momentum is always conserved, right? What is the initial momentum? The initial momentum is 0. Why? Because the trolleys A and B, as it says here in the question, they were initially stationary on a track. So the velocity was equal to 0. Momentum is equal to mass times velocity. If velocity is equal to 0, then momentum is 0, right? So initially momentum is 0. Well, what's momentum afterwards? Okay, let's just write after. So the trigger's been pressed, then the trolley A and B moves away, opposite direction, away from each other. So what's the momentum after? Well, the momentum after is also equal to 0, right? But let's first resolve. Let's just find. So the addition of these, the trigger's been pressed. They were first at stationary, then the trigger's been pressed, and now they are moving at a speed. So they have momentum, but the net momentum must be 0. Okay. So what's the momentum of A and X together? Well, first of all, actually before resolving, let's consider the right side to be positive and the left side to be negative, right? So the momentum of A and X must be velocity times mass, obviously, and the velocity is going to be minus 0.25 multiplied by the total mass, which is the mass of A plus X, and the mass of A is 0.5 as it states in the question, as it told us already, plus X, and is negative, just to remind you again, just to remind you, because as I said, the left side is negative and the right side is positive. So minus 0.25 times by 0.5 plus X plus the momentum of B, which is 0.30 multiplied by the mass of B, which is 0.5. And this is equal to 0. Since, as I said, momentum is conserved, right? So what we can do now is take this to the right side, okay? Because I just want to make this positive. I want to basically rearrange, and now I want to make X on its own, because that's what we're looking for. So 0.30 multiplied by 0.5 equal to 0.25 multiplied by 0.5 plus X. And we know that. And so 0.3 times 0.5 is 0.15 equal to 0.25 multiplied by 0.5 will give us 0.125 plus 0.25 multiplied by X, which is 0.25X. Okay. And so we can just take this 0.125 to this side, and we get 0.025, and that is equal to 0.25x, and then we can now divide both sides by 0.25 and we can get x, and so x is equal to 0.10 kg. Okay, so we've just shown it, just answered the question now. So let's just quickly do a quick recap. Okay, so basically part A wants us to tell us that what speed does the trolley A have, and we said it must have the speed that is it must have a lower speed than B, so it must have 0.25 meters per second, and that's because the trolley A has A and X have greater mass than B. And part B is essentially just using the conservation of laws principle. You know, the momentum before is equal to the momentum afterwards, and we know that the initial momentum was equal to 0 because the trolleys were at rest, and so the momentum after must then equal to 0. And yeah, so we just basically rearranged and found x. Yeah, and hopefully this helped you, helped everyone, at least maybe given some idea. You know, I'm a student myself, second year of university, as I've mentioned in the previous videos. If I do any mistakes, please tell me. If you're unsure about something, confused, please tell me. If there's any way that you know that I could improve on, or any ways that I could basically become better at teaching, please do tell me. I would appreciate it. I would be very happy. Yeah, thank you very much.